Alright guys, welcome back to the last portion of our Python Essentials class where we're talking about strings. Now, when it comes to strings, what we're talking about right now in this specific video is something referred to as what we call built-in methods. Sometimes you'll just hear it referred to as a string method. Now, every data type in Python, whether we're talking about lists or dictionaries or strings, will always have what are referred to as methods. Now, specifically, we're going to be talking about string methods. Now, the cool part about string methods, or any method for that matter, is that it's going to be kind of like a pre-written set of instructions that allow me to be able to do things. So as an example, I have the capacity of being able to determine whether or not a string is made up of alphanumeric characters. I have a way of being able to look at a string. Let's just go ahead and say x equals Terry. And I could determine whether or not it's capitalized. I could actually determine whether or not or change it from what it is to all uppercase characters. I can look at it and see, like I said, is it alphanumeric? Is it numeric? Because as an example, like for instance, when we were talking about casting, I could not cast Terry as a string into an integer or a float. However, I could write a script to look at it first and determine whether or not it could be casted into an interface or into a float. And that's what we're talking about right now, and we need to look at the tools that we have. Now, what I'm doing is I'm actually back in the Python script called Intro to Strings, and we're beginning at line 122 where we're going to be talking about string methods. Now, if you want to get a detailed listing of every string method, you can actually type directory and you can type in whatever it is you're looking at. So for instance, if I look at strings, this is going to be give me a detailed listing of all of the things that I can actually use. So we see a number of components here as far as directory string, but I find this to be not quite as useful. So as an example, we see here I have rs strip, I have rs split, I have r partition, I have write justified, I have is it an identifier, is it lowercase, is it numeric. And this is indeed useful, but my favorite way of being able to do this is to come in and say, as an example, if I wanted to look at, say for instance, a string value. So let's say x equals, and I'll say Terry. So x is Terry. So now if I come over here and I say x, and I look at the functions here, since x is a string, so here's what I'm talking about. So if I say type x, x is a string. So the system immediately knows that if I'm going to be working with this, it's a string. So if I want to look at all my string methods, if I hit the configuration here where I say string and I hit tab twice, it's going to give me a listing of all of those functions. Now, I don't know about you, but I find that much easier to read than this. So as an example, we can look at a number of things that we have here. Is it an alphanumeric? So if I say is alphanumeric, yes, it's an alphanumeric string. Is it lowercase? As an example, let's just take this guy right here. So is x lowercase? False, it's not lowercase. Is it uppercase? False. Why? Well, x has one uppercase character, and the rest are lowercase. So it doesn't satisfy those requirements. Another thing that we can also look at is going to be the help feature. You'll see that on line 26 in the Python script that I've written. What you can do is you can come in and you can say help, and then what you can do is you can get help with a string method, and then you type in the string method value that you're looking for. So as an example here, we used find. Well, I could come in and say is lower and go ahead and close the field here, and it's going to tell me it is lower. Tells me how to utilize the syntax, and it says returns a true if the string is a lowercase string, false otherwise. A string is lowercase if all cased characters in the string are lowercase, and there is at least one cased character in the string. So hitting Q will take me out of that. So again, that's a very powerful utility to allow you to be able to figure out exactly what your options are when it comes to this concept of string methods. Now I'm going to highlight a few of these because a lot of them we actually use in the class. So what I'm going to do is I'm going to create a variable here called my_string. So if I paste that in, I now have my _string. Remember what that's called? It's not a camel case, it's called a snake case. So here we are learning Python. Now I can actually come in here and execute the name of my variable. So it's going to be string. And I can come in and say, is it upper? Just like we did before. But notice I didn't say is upper. I said upper. So if I look at upper, if I come in here and I say help string dot upper and close this out, it says it returns a copy of the string converted to uppercase. Q twice, well, once in this instance, I'm sorry. And all it did was basically just capitalize everything. Now if I come over here and said is upper, no, sorry. If I come over here and say is upper, false, no it's not. Is lower, no it's not. Now I could actually come over and say, in this instance, I could say z equals my string. And what I'll do is I'll say upper and deploy it. Now I have x, which is going to be my name. I have my string, which is going to be, we are learning Python with the first letters capitalized. But if I come in now and I say z, notice that I now actually have the exact same thing, but all of the characters are going to be in uppercase. So these are useful tools that we can come in. Now I could come in here and say z dot, we'll say lower, and I could convert it back down to where every character is lowercase. Other things that we can actually do here is I can actually strip information. So here's a perfect example of what happens when we query a device. So if I go in and I execute a show run, and then I capture the results of that show run, a lot of times we end up with spaces that we don't want. So as an example, we can see here I have a space, 2 spaces before the IP address, and here I have a space after the IP address. Now I don't want that, because if I send that data from, say for instance, a Python script that I'm writing to a particular device, it may balk at these spaces. So a very handy tool is going to be the strip feature. So if I come in here and I say that I'm going to say my_IP and dot, and then we'll say strip, and if I leave the field blank, it's actually going to remove all of the spaces. Now it's stripping to the left and to the right of the value. Other things that we also may do is if we had characters, because this is how I would strip a regular blank space. But what if I modified my value here to equal, let's go ahead and add those $signs. We may not actually have $signs, let's just say we have dashes that we're pulling out. So all I got to do is just use the variable, the strip keyword, and then what it is I want to strip out. Sorry, got to use brackets for that. No, I got to use quotations because I got to filter out the exact value. So I'm filtering out any component that actually satisfies this requirement. So you can see here I have the little $signs for stripping. Now what if I only was interested in the leading space? So as an example, if I go back to the original value here where I had all of this, all I would have to do is basically I could use L for leading strip. So if I come in here and say my_IP and I say .L strip, and then I use the space fields, notice it just removed it from the left hand side. I can also do trailing, so it's going to be the right hand side. So if I come over here and said R strip, but notice that it didn't affect the variable. The variable is always the same. In fact, if I look at my strip, my IP, excuse me, it is exactly the way it was. So I can actually do a number of things here. Now, we also need to mention, remember earlier on I said if we came in and we defined something like my string, And I said that if I used quotation, single quotes, my problem is I could not use single quotes in my configuration. So if I came in here and I said, I'm learning Python, and hit enter, it won't take it because it sees this second single quote as the end of the delimiter. Now I could and can actually change that behavior, because all I've got to do is come in and put in a backslash, and what that's going to do is that backslash is actually telling Python to ignore this single quote as being a delimiter. So it's an interrupter. Now if I come over here and I say my underscore string, notice it doesn't have that backslash in there. So again, that's also something that's really useful. It's not really a built-in, but it does give me the capability of being able to put in an interrupter in there. It's basically interrupting the parser and saying, hey, ignore this single quote that's in this line. And you can use multiples of these, obviously. But now I've got this I'm learning Python output. Now, strings. If we look at strings, we have to understand, as I mentioned in the very, very first part of the series, variables, strings are what we refer to as immutable objects. So if I come in here and I say x equals Terry, and then I print x, and then I type ID of x, notice it placed the value of Terry in this memory space. But if I come over here and I modify it, I say x equals Terry with a capital T. Now it's capitalized. If I type ID of x, what we're going to see is it moved it to a completely different memory location. So that means that variables that are strings are what are referred to as immutable. They cannot be modified as they are. If they are changed, the old value must be deleted and a new value must be created. Now, we also, what if I didn't want to actually leave everything the way it is? So right now, let's say that, my wife, her name is Sheila, and her last name was Johnson. Now, x is a value, and if I do ID of x, what we see here is that's the memory space that it was stored in. Now, when we got married, her last name changed. Now, using a built-in method, a string method, I could actually come in here and I can replace a character or a value inside of a string. So as an example, if I come in here and say x equals, and then what I'm going to do, I'm sorry, not x equals, I'm going to say x dot, and then I will say replace. And what I'm going to do is I'm going to replace Johnson, if I spell it right, with Vincent. Now, basically in this scenario, her name has been modified, but the original value of x still again remains the same. If I wanted to change that, obviously I could come in here and just simply say x equals x. Now if I take a look at x, it's been changed, but again, remember, they are immutable values. So what ends up happening is it was actually deleted and recreated and assigned to a new memory space. Another thing that we also may want to look at is going to be the fact that I might need to split values. So as an example, let's say we did have an IP address. Let's say I have my underscore IP equals, and let's go ahead and say 192.168.1.3. And let's say that I'm interested in manipulating this, and what I want to do is I want to see all of the individual values, and then what I may want to do is I may want to read later on a specific one. Well, one of the things that I could do is I could say my underscore IP dot, and I can use the split feature, and then I can say I want to split based on this field right here. And what that's actually going to do is notice it's going to create a list. In fact, if I come over here and say x equals, and I say, actually it'll be easier to just write over and just say x equals this field. Now if I print x, notice it's in brackets, and if you'll remember from our introductory video when we were talking about data types, that is a list. So if I come over here and say type set up, notice that it is indeed a list. Now, a list can actually be indexed. So now if I were to come in here and say I want to look at X, specifically I want to look at index 2. So remember, indexes start at 0, so 0, 1, and 2. I could actually look specifically at the third octet. So that, again, gives me capability of being able to do things. Also, I could limit based on white space. So sometimes, as an example, let's say X equals, we are learning about strings. Well, one of the things that I could do is I could actually use that split function again. So up here is my split. And what I'm going to do is, instead of splitting on a field, I'll just leave it blank, which means it's going to split on white space. And if I come over here and hit X, notice it still made a list. Actually, I've done the wrong field, so my split, that's not what I meant to do. So X, my apologies. So I need to say X, not my split. All right. Now, interestingly enough, I should have just created a list of every individual word where the space has been processed. But I've got an issue here that's interesting. So when we look at the fields value, so let's say X, I'll say X, and I want to look at, let's see, 0. So there's we. So if I look at 1, there's R. If I look at 2, learning, 3, about, and then 4, strings. Now remember, we can't go out past the 5th value or things are going to actually crash. But what this does is this allows me to be able to take a string and generate a list. So it's not quite like casting, but the outcome ultimately ends up being the same. Now, we also have features that like I said, I can use split. I can also join values. So when we look at things like my list, so I'll come back up here and I will, he's got my list, or I've got my list. So let's do this. I'll create a my list. Sorry. I need a working list. There we go. So there's X. So in this scenario, what I'll do is I'll create my list. And I know we really haven't talked about lists yet, but my list is actually going to equal the my, or it will be X dot split. Let me close my mail. I apologize, guys. I always forget to do that. Amazon wants to sell me flowers for my bees. So X, and then what I'll do is I'll split on this field, and now when I do my underscore list, I should actually have a list. Now, a list can actually be recombined. So what would happen if I came in and said, I want to take this list, and what I want to do is I'm going to join it. Now, a perfect example of this would probably be, let's go ahead and make a list. So we'll make a list, and I'll just do open bracket, and we'll say 10, comma, 1, comma, 100. And I'm using these as strings, 100. And we will have, let's say, 5. Close bracket. Now that constitutes an IP address. So if I come over here and say X, it's a list. Type X. Tells me it's a list. But what if I wanted to combine this list into a string? We saw how I can actually combine or take strings and make lists out of them. Well, what if I wanted to combine them? Well, what I'll do is I'm going to say that I want to use a value of dot, and then I'm going to use the join syntax. Let's see, I'll need to use, give it a try, join, and I'll say X. Now notice what that did is it actually took those individual list fields, those indices, and combined them into an IP address. Now obviously IP addresses can't be integers or floats. More specifically, they can't be floats because we have more than one decimal point, and that violates the rules of how decimals work. I can actually determine whether or not information is in here. So let's go ahead and do that. Let's go ahead and combine this and make it an IP address. So what I'll do is I'll say my underscore IP equals the result of that join operation, and my underscore IP has 10.1.100.5. I can actually use in and not operators. So as an example, can I say, is there a 192 in my IP address? So I'd come in here and say my underscore IP. False. I can actually do the reverse and say not in. Not in. So yeah, it's not in there. Now this gives me the capability, I can actually do this comparison on many IP addresses. So I'm just using this as an example of one. I can come in here and say, is 10 in my underscore IP? And sure enough it is. Now another thing that we can do is, a useful one here is, you'll notice that I've got a string value here. So I'll copy and come down here and paste. Now I've got my string, and in my string I actually have two values in here. It's the same sentence. This is my string, this is a string, this is a string. Now what I can do is I can actually sort on this by using that find keyword. So again, if we come in here and we say help string find, we see here that it's the find option is going to return the lowest index in S. That's what this field is, the variable S, where the substring is found, such that the sub is contained within S, either at the start or end. Now the problem with this is that sometimes those help messages aren't that helpful, so we really need to actually try to execute some of these commands and play around with them. And that's what this portion of the series is about, is exploring what happens when we execute these values. So the question is my string find is, and what it's doing is it's actually coming back and it's telling me how many times is actually in that value. If I were to come in here and reverse this and go SI, primarily what we're seeing here is we have a -1 value that's coming back. So what that's saying is that if I reverse this, it's actually in or showing up in the configuration. Another thing like I could do is I could capitalize it. So if my string, and what we'll do is I'll say capitalize. Oh, I'm sorry. Open and closed. So this is a string, this is a string. Now what got capitalized? The first T. So if we look at capitalize, capitalize is going to do exactly that. It's going to capitalize. If I wanted to turn them all into uppercase, I would actually have to say upper. I could determine, and I've already demonstrated this, we can do is upper, we can do is lower. So I can actually combine logic. So a perfect example of this is right now I have my underscore string. And right now it's all lowercase. Now obviously I could execute the same script or the same command that I executed before and say my string, and I could say lower, or we can say upper. Actually we'll do lower, same as we have here. And what that's going to do is that's going to print it in lower. And then what I could do is I could say is lower. So what this is allowing me to do is I'm actually nesting these values. So it's actually taking the string, running the syntax to it, make it all lowercase, and then determining whether or not it is in a lowercase value. If I were to modify this and say upper, what we're seeing is now it's false. So we can actually string methods together using this decimal integration. So, like I said, we've got this whole idea of whether or not something is a digit, whether something is alphanumeric, whether or not something is numeric. So if I come in here and I say x equals, and I say 1,000 or 10,000, and then I say dot is, so let's say I want to cast this. So if I come over here and I say I want to cast it as a string, so let's just say, not string, but an integer, x. I can cast it. Just to demonstrate that point, it is casted. Type y should be an integer, which it is. So it does cast. But what if I couldn't cast? So as an example, let's say I have an a in here. So now can I cast it? Can I come over here and say integer x? No, I can't. Why? Because it says integer works with base 10, and I have this idea of a in there. Now, what if I change that? What if I come in here and said z? Is it going to give me the same error? Yes, it does. So a lot of people are looking at the a, and some of my network people say, well, is that because it recognizes it as hex, which is base 16? No, it's just saying I can only take a base 10 number and convert it into an integer. Also, another part of this would be, well, what if I wanted to check first? So could I say x dot is digit? Notice it's false. But if I come over here and change the value back to an actual number and we do is digit, notice it is true. So I could actually integrate the logic into my script to be able to convert resources based on being able to take an analytical look at what the actual value inside the variable is. Now this is going to wrap up our conversation about strings. And I know I covered a lot of ground. I want you guys to go through it very, very carefully and very slowly. Also remember that you have the field companion that is issued as part of this class, which is going to cover even more detail and offer some other examples than the ones that I'm showing in the videos. But the goal here is to get Python on your desktop or your laptop. Then the goal is to download these scripts, copy and paste and execute them. I use my editor, the Visual Studio Code. I love working with it. It's not the only one. Atom, Sublime, all of those can be used for this purpose. But the main thing that you want to do is make certain you understand what your options are. Because the hard part about writing a Python script for the purposes of networking engineering isn't really the idea of how to configure the network device. We know how to do that. We know to log in, we know to enter a password, we know to go to a particular interface and, for instance, configure an IP address, and we know to no shut that interface. Python doesn't know anything. So we have to be able to write a script that's going to tell Python to do what we want it to do, what we'd ordinarily do when we'd log into a device. And in order to be able to do that, we have to be able to convey that information in the language and in the format that Python expects. And we'll obviously rely pretty heavily on the idea of strings and string values. Now, there's going to be one other thing that I want to talk about when it comes to strings, and that's going to be the fact that sometimes I may not want the program, I may not want Python to contain a value for a string. So as an example, if I write a script and that script has a variable that is my username, admin, and a script that has the value that is my password, whatever that password is, super secret password, the problem is it's visible inside the script. So if somebody were to download my script from like GitHub or whatever, the possibility does exist that they could actually get the information that they need to be able to access my network device. God help you if it's accessed to like an AWS account, because within 30 seconds somebody will find it and you'll be mining Bitcoin and get a $30,000, $40,000 bill from Amazon. If you don't believe me, look it up on Google. It actually happened. So, you know, we have to be very, very careful. And one option that I want to talk about is going to be being able to write or tell our Python script to solicit us for specific pieces of information. And then what we'll do is we'll assign those pieces of information that we enter at the time of the execution of the program or the script, we'll enter it into a specific value. And again, this is going to be how Python will interact with us as users, and also how Python will actually interact with the machine that it's running on, in my case, my Mac. So what I'm going to do is I'll see you guys in that video. I'm going to wrap this up here, and I hope you're finding this helpful. and we're going to find ourselves moving into another data type once this module is completed. So the bonus material will be on what we call the get feature. I'll see you guys in that particular portion of the VOD.